Hello, and thank you for joining us for a special conversation with Carolyn Warren Wiley, Kim Denley, and Emily Atchley, authors of Beginning Statistics 3rd edition. My name is Shirley Ursery, and I am a math content editor here at Hawks. Today, we're going to be discussing a new edition of your book. The new edition is designed to help students develop a solid foundation and understanding of statistics. The information covered includes methods of conducting and critiquing a statistical study, hypothesis testing, confidence intervals, and regression. Updates include expanded exercise sets with real-world data, a modernized methodology for hypothesis testing, an emphasis on technology, and the ability to use different methodologies to arrive at correct answers. And now I want to further introduce the authors. Carolyn Warren Wiley holds a master's in mathematics from the University of Southern Mississippi and has completed advanced graduate work in statistics and mathematics education at the University of Mississippi and the University of Memphis. She is currently pursuing her doctorate of education at Delta State University. Carolyn is the Associate Vice President of Academic Instruction and Institutional Effectiveness at Northwest Mississippi Community College. She is an active member of institutional research organizations at the state, regional, and national level, including having held the office of president in both the Mississippi Association for Institutional Research and the Council for Institutional Research and Effectiveness for the Mississippi Community College Board. She won the Mississippi Online Instructor of the Year in 2010 for her courses in statistics at Northwest Mississippi Community College. Kim Denley received her bachelor's degree in mathematics education from Louisiana College and did her graduate work at Louisiana State University. Along with Beginning Statistics, she is co-author of Viewing Life Mathematically, A Pathway to Quantitative Literacy. She enjoyed her time as a mathematics instructor, teaching statistics, quantitative reasoning, and developmental mathematics throughout her career. Emily Atchley holds bachelor's and master's degrees in mathematics from the University of Mississippi. During her postgraduate work, she was selected as a National Science Foundation GK-12 Fellow, a program designed to enhance math and science education in local schools. Emily was a mathematics instructor at Ole Miss for many years, where she served as course coordinator for the freshman statistics classes. If you have any questions during the webinar, please enter those into the Q&A box located on the panel at the top or bottom of your screen, and we will address them at the end of the talk. So authors, we wanted to ask you all more about why you decided to write this new edition and some of your favorite parts of the book. Let's start with Carolyn. So Carolyn, why did you create this new edition?
Well, we started just to update the previous edition, update the exercise sets, update some of the real data to more current data. But as we went through, we had so many ideas. We just ended up doing a full-on revision, much broader than we imagined at the beginning. And of course, anytime you're writing a new edition, you want it to be the best yet, but we are so excited about this one. We truly do think this is the best of the three.
Great, thank you. Well, Emily, who did you write this book for? Who is the book for?
Well, we wrote this book for students and faculty who want an approachable and readable statistics textbook. In particular, we wrote this book for students who would be consumers of statistics with an emphasis on really understanding the meaning of the results. We really pride ourselves on the fact that our book is both robust mathematically yet also approachable because of its conversational style. The three of us, we're all teachers ourselves, and this is the book that we want in our classrooms. It's really both a great instructor resource as well as a book that our students can really understand.
Mm-hmm. Thank you. Kim, can you elaborate on how this new edition is relevant and impactful for students and instructors?
Sure. So how is it relevant? I think that we all agree that it's our belief that 21st century skills include data fluency. students are going to have to know how to not only use technology, the digital aspect of that, but have a firm understanding of data and how to use that technology with that. So it's going to be a must for college graduates in the coming years. And so in this edition, we made a concerted effort to pull in as many examples as we could to touch lots of subject areas, but also as many careers as we could as possible. So I think we have a slide to show an example. So in chapter 4, when we talk about classical probability, this is one of those examples. We looked to sort of the biology department, and we pulled in a Punnett square, something that biology students will all have to encounter. And so if you can flip to the next one. So we actually have the Punnett square, but it's not imperative that you understand how they work necessarily to do the probability question. But you can see on the side, we put a side note to talk about a little bit about the Punnett square and introduce it to anyone who might be unfamiliar with it. And then also when we talk about the central limit theorem, what we did is we went, Danny, if you could move on to the next slide. I think I have an example there. Yes, so when we talk about the central limit theorem, we use some entry-level salary data from law school graduates. So whether or not you're going to be in a STEM career or not, we tried to touch a different portion of students who might be considering law. So
Yeah, that's great.
That's on the relevant side. How, as for impactful, Emily, I think you put it best. We have kind of, with our writing style, consistently, we believe that it is robust and approachable, and we believe that it's approachable for not only the student, but also the lecturer, the instructor, faculty member. And we kind of have aimed to do that in all 3 editions. And so we truly see our book, along with the software, as part of the teaching team, that it's all 3 of those together. And so that's what I would say is most impactful about it.
Thank you. That's very helpful. Well, now I actually have a question I'd love to get all of your feedback on. I was wondering if you could each share what is your favorite part of the new book?
Well, I'll go first since I was talking, but my favorite part continues to be our projects at the end of each chapter. We kept the old tried and true ones that we always love, and then we updated some of the other ones. So for instance, in one of the chapters when we talk about, I think it's chapter 9, we talk about making confidence intervals for 2 populations. We have one that, we have a choice of 2 actually. One of those pits students against faculty, because we always know how much they love to do that, about screen time. This one that's showing on the screen right now is how good is your historical knowledge? So pre-test, post-test. But with both of these, you know, the students in our projects have to go out, they have to collect the data, but think about how they're going to collect the data, and then come back, calculate statistics, and then analyze the data. So it's really kind of hands-on. And I think in chapter 12 about regression, we added a new one about arm span and height. And so Carolyn actually did some data collecting for us from her family.
Yes.
And, yeah, so just kind of going out and collecting data about that again. And what we did that's a little bit different in this edition, besides updating some of the projects, is we tried to include some example data. So we have that on their website. So both faculty and students could go and kind of look at what happens if someone else's data looked a little bit different than mine. But also we provided potential answers. A lot of our questions are open-ended, so we tried to provide solutions to most of the projects this time.
I'll go next. My favorite part is the updated format with the example solutions. in the previous edition, we would have multiple methods or multiple uses of technology. And they would be sort of laid out, you know, this is method 1, this is method 2. And this time what we did is we sort of incorporated them all into the same process. So as you can see on the screen, if you're drawing a conclusion for a hypothesis test, you can use rejection regions or you can use p-values. So we have, here's step 4, draw your conclusion. Here's method 1, if that's the method you're using. Here's method 2, if that's the method you're using. And even within method 2, we say, in order to use p-values, you could do it with tables, or you could do it with the TI-84, or, you know, Excel. There's all different ways in which to do it. And so students can simply follow through using the method that they choose at each step. And so I like how they're incorporated together instead of looking like 5 different solutions, because we didn't want them to think they were different solutions. It's one solution, there's just different methods of arriving at it.
Well, I'd say that I really love our approach to technology in this edition. So in the previous editions, technology was relegated to the end of each chapter, and it was more of a reference section. And I really love that in this edition, we chose to integrate the technology into the text and into the example solutions. So visually, you can see the different technology options that are available for finding each solution, and they're right there alongside the traditional approaches. So we're hoping that this new structure will make the technology solutions more accessible to the students, since the solutions are just right there in the chapter rather than off at the end. So the example that I chose to illustrate this technology change is from chapter 6. It was kind of a fun one about kids at Splash Mountain in Disney World. So you're looking for the percentage of children that would meet the height requirements for Splash Mountain. And you've got, in the previous edition, for this type of example, we would only show a traditional method with the tables, which is a great way to work the problem. And then if you wanted to give a technology solution with the graphing calculator or with Excel, you could go to the reference section. But now in the 3rd edition, it's just right there in the text. So not only is it easier to find, but I feel like visually for a student or an instructor, you can see right there that, oh, you know, the graphing calculator solution is just as easy as a table solution. Now, I will say, if you like the reference section, it's not gone.
Right.
It's on the Hawks website, so it's all still there. It's just not holding space in the textbook anymore.
Well, that's all so exciting. Thank you all for sharing those great new features. I would love to hear a little bit more about the technology you were talking about. I was wondering if Carolyn could expand on what Emily was saying about the emphasis on technology.
Of course. Thinking about data fluency being a must-have for graduates. And of course, my role is an institutional researcher. So I am a statistician by trade. That's what I do day in and day out. And I am going to run to my technology as my tool. We want to really focus on the fact that technology is the tool that can help you find the number you need. It is not going to give you the solution. It's not going to interpret it for you. I tell my students in class all the time, your calculator is only as smart as the person using it. You don't tell it to do the right thing, it can't do it. And so that's how we've really structured this edition, is that technology is a tool to help you solve the problem, but it still requires thought into that process. And then we also, as a tool, we wanted to tell them what other tools are out there. So we found some great apps. We mentioned Google Sheets, which is a good free version of Excel if their college or university doesn't have an Excel license for them. So we tried to make sure that the technology was as accessible as possible, because a TI-84 calculator, though it's great and I love mine, it's an expensive investment for a student that may only use it for those introductory statistics courses or maybe 1 or 2 other STEM courses. So we did really try to focus on just what tools are out there. We've also expanded what technology we actually discuss in the book. So even though we had Minitab and Excel and things like that in our technology sections at the end of each chapter, and like Emily said, none of that is gone. That's all on the Hawks website, as well as information on how to use R and some other statistical software packages, SPSS. We did try to bring Excel into the text itself this time. So in particular, when we mentioned it before with ANOVA, but this time we use it in confidence intervals, we use it in hypothesis testing. I think there's maybe even a screenshot, Danny, of where we have some examples of how we've put Excel in. Notice here, we're calculating, I believe this is what are we doing, a correlation here, pair difference. So we're doing the pair difference by hand because we're just doing a subtraction. And then we've got how to really quickly do this in Excel as well, which, you know, personally, that's how I would be doing it if I were sitting at my desk working on this type of problem for my college. Another example where we show two different types of technology is in our linear regression example. So you can see here, here's the question. It's asking them to find the correlation coefficient. And so then we show them, here's how you would do it with a TI-83 or 84 calculator with a screenshot. And then we also give them the Excel formula that they can use right there. So again, just using different methods. We even do have some screenshots, as you can see there, of what the Excel page actually would look like.
Wow, thank you. I can really see how that would be valuable to all students, no matter what technology they're using.
Absolutely. And these Excel formulas, the formulas in Google Sheets are very, very similar. Most of these directions can be used. We also found smartphone apps that mimic the TI-83 and 84 so closely that a lot of our directions can actually be used on those apps as well. And those apps run like $5.
That's great. Thank you. Okay, another thing I wanted to bring up is that in Chapter 6, you expanded and rearranged the topic of normal probability distributions. I was wondering if maybe Kim could expand on that a little bit?
Sure. So Chapter 6 on normal probability distributions in the past two editions have been similar to what other statistics textbooks look like. You sort of cover normal distributions, all of them, and the standard normal distribution all in one section right at the beginning. And because I think technology hasn't always been so readily accessible, the standard normal distribution has up until now, been an excellent means of calculating the area under the curve. But as Carolyn just said, you know, now that apps, smartphones are everywhere and our students have them, and apps cost like $5 instead of a couple of $100 to buy a calculator. Standardizing every single normal distribution is no longer a must do because we have better means and quicker means of calculating the area under the curve. So what we did, instead of cramming that all into one section at the beginning, we took section 1 and just talked about what normal distributions are. And so the properties of them, and we didn't even mention the standard normal distribution. And then in section 6.2, we said, hey, here's a little bit of a history behind why we have the standard normal distribution, what it was used for, and here are the traditional methods of how you can go about standardizing any normal curve to the standard normal distribution. Then what we were able to do is, in the remainder of that chapter, is put it back in the hands of the instructor or the student and say, how would you like to go ahead and solve this? So I think we have an example, let's see, in section 6.3, yeah. So we have an example, we're trying to see what the area to the curve below a certain value is. So we begin the solution at the top by saying, okay, here's what it is that we're looking for, i.e. the area to the left. And we don't actually even say what method you have to use. We break it down, and I think you can see at the bottom of the screen there, tables. If you're going to use the probability distribution tables that are in the book, then what do you need to do first? You're going to first have to standardize it. And so we walk them through using the standard normal, the z-scores. And then in the next bit of the solution, we say the TI-83 plus, we give that option. We say if you're going to use that, then it's not necessary to go ahead and standardize it. And here's how you can just type that in real quickly to your calculator, and we give the answer there. And then at the end of that, because we realize, you know, it's a preference about what, for the instructor and the student, about which method you're going to use, we come back at the end and we say, okay, so whichever method you use, and sometimes the calculator is a little bit different than the tables because they can be more precise, and when in that case we do mention it a little bit, but we say what it was, whether both methods produce exactly the same number, and then we reiterate the conclusion based on what was first given in the problem there. So yeah, I think it's a more robust chapter about normal distributions than we have. We previously focused on standard normal distributions.
Thank you. That's very thorough. And it's interesting to see how things have changed because of advancements in technology, how that's going to affect a book layout, for example. So that's really great. Thank you. We were going to save most of our Q&A for the end of this talk, but someone had a follow-up question to what Carolyn was talking about. I thought I'd just go ahead and interject it here. So we have a question for you, Carolyn. The question is, do you think that you overcompensated with the technology? I know that in Maryland, many of the universities are not allowing calculators at all for math through calculus. So where did you stick to the traditional method? And do you have screenshots of technology and using the charts also?
I think that's a great question. And I don't think we overcompensated at all. In fact, as Kim just mentioned, throughout the entire book, I think there's literally only one concept, and that is calculating the correlation coefficient, that we did not show how to do it by hand, that we did not show how to use the charts, that we did not provide the charts within the textbook. I know in teaching this class online, there are a lot of times where I need to use something like a lockdown browser that would not allow them to have access to other technologies, so they need to have some other option available to them. So we made sure that all of that was still there. Chapter 4 is another great example where there would be, here's how you do it by hand, here's a snapshot of the chart, here's how you would use a calculator, here's how you would use maybe Excel. And you have multiple options there. So again, it's kind of a choose your own adventure. And so if the students are not being allowed to use certain technologies, that should not be a problem at all. Great question, thank you.
And chapter 4 is probability, when she said in chapter 4.
Oh, I'm so sorry. Yes, chapter 4 is probability.
Table of contents memorized.
Okay, well, thanks for that follow-up. That's helpful to get that clarified while we were talking about it. And so continuing on, another change in the book is that there's been some changes to Chapter 7, the central limit theorem. Emily, would you mind expanding on that and telling us about those changes?
Sure. Yes, we made some changes to Chapter 7, but it was nothing too extensive, no worries. The main change is that we opted to flesh out the concept of sampling distributions a little bit more at the start of the chapter, rather than jumping straight in with the central limit theorem. So we use the same die rolling example to explore this topic, the same example that we used in the last edition. So we then define a sampling distribution of sample means, and we give its mean and its standard deviation. So then only then, after we've laid this good foundation of what a sampling distribution in general is, do we go forward and introduce the central limit theorem and talk about how important it is. So I really think that the way we work into these topics in the 3rd edition sets up the motivation for the central limit theorem really well. Also, just to note, the central limit theorem is defined a little bit more broadly. We don't include the mean and standard deviation because we covered them first when we talked about sampling distributions.
Great, thank you. Thank you for sharing, for informing us on those changes. And another change in the book that here at Hawks, we've already been getting lots of questions about is the new methodology used in hypothesis testing. I know there were major changes made there, and Carolyn, would you expand on those, please?
Absolutely. So in both previous editions of our book, we wrote the null hypothesis as the strict mathematical opposite of the alternative hypothesis. And in this edition, we switched to writing the null hypothesis using only an equal sign. So both methods are mathematically accurate, and I've seen both in many places and used by statisticians in all different arenas. The null hypothesis, as long as it's a statement of equality, that will work. However, using a strict equal sign is a more conservative method of testing the hypothesis. Also, it's in keeping with the other Hawks software and textbooks that are statistics textbooks, so we wanted to be sure to do that. I've seen that sort of shift in other textbooks that are on the market as well. And to be honest, when I'm teaching my classes, my students default to putting just an equal sign, and then I would have to tell them, no, we need to write it as the strict mathematical opposite. So they kind of defaulted to that because we're teaching them that the null hypothesis is the assumed value of the parameter. So they're wanting to say, well, it right now equals this value. And so that allows them to do that mathematically accurately.
Mm-hmm.
Yeah, that makes a lot of sense. Thank you. Let's see. So I understand that you've added a new critical thinking step, interpreting conclusions for hypothesis testing. So Kim, would you like to introduce that?
Yeah, so building off of the idea that we want students to sort of engage with the question, I think that we all are, we're all aware that students still believe sometimes that the answer in a math class is a number, right? And they get a number and they're like, I've got it, and you know. So what we wanted to continue to do, and we hope that by emphasizing it a little bit more, that we want to emphasize that it's not just a number, it's the conclusion about interpreting that number based on where you started with. So for instance, I think we have an example here where you can see down at the bottom, we've given the method as a p-value, and then right for the tables, the calculator, and then underneath it says comparing this, the conclusion is to reject the null hypothesis. And how many students say, I'm done, right? I got reject or not reject. And so right under there, we said interpretation. So we want to note to them that no matter which method you use, you still resulted in a rejection. What does that actually mean now based on what the original question was posed? I think that this also helps with critical thinking, because if you were to pick up a different textbook, say our last textbook, which the second edition, which Carolyn just said, didn't write the hypothesis the same exact way as we're writing it now, we want students to engage their brains and say, well, if a different textbook doesn't lay it out the same, or a different student in a different class, their teacher taught it a different way, do my answers actually match one another, and are we saying the same thing? And I think that's where the interpretation comes in, because you're putting it back into the phraseology of how it was phrased to you originally, and so that you can, just compare answers a little bit better. So we just highlighted that, and I think that's really good.
Yeah, that is a fantastic thing to highlight. That really will help students understand and comprehend what it is that they're learning. That makes a lot of sense. Thank you. Let's see. We want to hear, we've also been getting some buzz about the new expanded exercise sets. So Emily, would you mind filling us in on what the changes are with the exercises? Sure,
I would love to. So all of the exercise sets were updated to use current information. The exercise sets in this newest edition are definitely more robust than in our previous books. So I'd also like to point out that we made a concerted effort to match the difficulty of the even and odd sets of problems. I believe this was a user request, and it was a really good one. So now an instructor can assign either just the odd problems or just the even problems, and they'll cover the same concepts with a similar level of difficulty. So we are really happy with this improvement.
Mm-hmm.
Great. Thank you for expanding on that and clarifying. Okay, so I know you're excited about how the new edition continues and expands upon the way in which it aligns with the GAZE guidelines. Can you talk a little more about BEG3 and GAZE? And I believe we have a slide of the 6 recommendations from the guidelines for assessment and instruction in statistics education. So if you could each maybe talk on some of those points and tell us how BEG3 fits into these guidelines.
Sure. I'll take a first couple on those. In the GAZE guidelines, if you look at the screen, that bottom quote there is a direct quote from GAZE. We should teach students that the practical operation of statistics is to collect and analyze data to answer questions. And in hindsight, that has been and continues to be our driving force behind BEG. Like from chapter 1, where we talk about the process of a statistical study right off the bat, we don't jump into probability and all that. We just talk about why and how a statistical study is done, right through to the end of, we talk about hypothesis testing. And at the end of the section, we say you have to choose which tests that you're going to run to do a test. So we want them all the way through to be thinking, how do I collect this data? How do I analyze this data? What question am I answering? And it's not just a, run the numbers kind of thing. The second GAZE guideline is focus on conceptual understanding. And I think we've touched a little bit about that as we've gone along, but I kind of want to highlight a couple of things. So the chart on the left is a chart from chapter 10 about hypothesis testing. Again, what I mentioned before about choosing the correct test statistic. And so what we wanted to do was emphasize the bigger picture of the hypothesis test. And, oh, you're at this stage, which test will you actually choose to run out the hypothesis test? So we provide charts for both chapters 10 and chapter 11 when you do multiple of those. On the right, you can see that there's an example from chapter 1's exercises, and we tried really hard to make our chapter exercises, well, just as the instructions there say, respond thoughtfully to the following exercises. A lot of them are open-ended questions, and so we again put possible answers might include. So pushing students to think about the concepts rather than a lot of rote calculations. They need to know the rote calculations. They need to know vocabulary. So we put that in there, but we really do emphasize the conceptual understanding as well. Another thing that comes to mind is when we talk about confidence intervals, we don't jump straight into, oh, look, here's E, here's how you calculate it, and then when you get E, here's what you do. We talk from the beginning about what are the advantages of doing a confidence interval, what can you find out about it. Even before we introduce how to calculate E, we say, here's how you build it once you have E, so that you're kind of learning the concept of that rather than the number crunching of how to find E. So I think we do a pretty good job all the way through on that.
I'll go ahead with number 3. Number 3 is integrate real data with a context and purpose. And we certainly have what I refer to as textbook examples, which are problems you're only going to encounter in the textbook. But we intentionally use those and reserve those where we're wanting to explain the process in a very simplistic manner before we expand it out to that conceptual understanding. So the majority of examples and exercises use real data within a context, and then we ask students how that might relate or how they would actually use that data.
Mm-hmm.
One example we have here is in chapter 2, we're introducing heat maps, which is actually a new feature. And that heat map, we're talking about population. And instead of just asking them, you know, which states have the largest population, we actually ask them in terms of a business concept. How would you use this information to decide where you might open a children's clothing boutique? And then we even expand upon that same information in the exercises with some additional questions and some additional thought exercises. And we also introduce these heat maps because we're beginning to see newer graphics. These are graphs that are very often seen in the news. So we wanted to make sure that the things that they're going to be seeing, that data fluency, are things that we're including in our textbook. And then number 4, foster active learning. So active learning is the 3 of our favorite way to teach any concept, much less statistics. And in fact, I always particularly ask for those long hour and 15 minutes or 3-hour time blocks for my statistics classes, because I always wanted to introduce the chapter via a project. And a lot of the projects at the end of our chapters are those projects that I would use, or that we would use in class to introduce these concepts. So for example, in chapter 4, we're talking about probability, and one of the concepts is the law of large numbers. Well, instead of introducing that concept via lecture, you could introduce that concept through that project in class. And that is how the 3 of us typically actually even taught that particular concept. Another example is where in the central limit theorem, we actually have a project that introduces that, and they can actually do a simulation to see how the curve changes and becomes more of a normal distribution as you change various parameters. And so it is building and creating their own knowledge instead of just receiving that knowledge passively from a lecture.
Okay, I'll cover guidelines 5 and 6. So 5 is to use technology to explore concepts and analyze data. We've talked about technology a good amount. So we cover a wide variety of technologies in our text. And as mentioned before, we have integrated these technology solutions into the text of the chapters, as well as the chapter examples. So on the PowerPoint, I have an example here from chapter 12 to illustrate how we meet this guideline. So in example 12.1.4, we are looking at linear regression, and we've got a scatter plot. Let's see. Danny, can you show the rest of, there we go. There it is. So we're looking at different things with this paired data. And you see we've got 2 different types of technology that we use to explore the correlation. And that's just one example of how we've tied technology throughout the textbook. Then the 6th guideline is to use assessments to improve and evaluate student learning. And I think this is where we really benefit from our pairing with the Hawk software. Our textbooks, exercise sets, and projects are really great. But having the software as an assessment tool definitely extends the way you can evaluate students. Here I've got a screenshot again from chapter 12. And the picture on the left shows the opening screen and the different options for student learning. The learn, the practice, the certify, and then on the right, you've got an actual question from that chapter. Yeah, I think the software is just a real bonus for assessing students.
Wow, you really covered all your bases with those GATES guidelines. Thank you all for your insight on how BEG3 is meeting those guidelines and all of these great changes to the book. It's just been really exciting to hear from each of you, and now I'd like to open up this discussion to questions from our audience. We've already been receiving some throughout the talk, so I'll start with those, but if anyone wants to ask a question, you can use the Q&A box at the top or bottom of your screen and just keep sending your questions in, and we'll go from there. So I'll start with the one that's already been sent in. This is from Richard, and he says, The book has changed the criteria for when a normal distribution can be used as an approximation for a binomial distribution from NP greater than or equal to 5 and n times 1 minus p greater than or equal to 5 to greater than or equal to 10. The limit has changed. Was this intentional? If so, why? And most online sources I can find still use 5, not 10, as a deciding criteria values. So if any of you want to jump in with this question.
I'll take that one. Yes,
Okay.
Richard, that's a great question. And we thought about it a lot too. Both NP greater than or equal to 5 and N times P greater than or equal to 10 are both commonly used as deciding criteria there. So we ended up choosing in this edition to use 10 rather than 5. That was intentional. And it was because we wanted to be consistent with other Hawkes materials, and also because we chose to go with a more conservative estimate there.
Okay, thank you. Okay, another question was sent in to us. Do you all have ideas on how to explain to my students what should be done if mu is below the proposed number? And I assume this question is for a hypothesis test where your alternative hypothesis is a greater than.
Yes, so what a great question, actually. So I guess the question is, what happens if a student says, oh, mu is less than the actual equals to thing? So I would open that up as a great class discussion. And first of all, say, what would you be expecting if you collected all this data and you're trying to prove that it's, that it's more than, and you end up with actual less than number when you bring your data in, and open it up to class discussion about what they would expect, where they would go with it, and then talk about what that means with your data compared to what the test that you're running. Girls, what do y'all have another input on that one?
Yeah,
No, I think that's exactly right.
Yeah, I think you could work the problem as is. It's going to work. You're going to get a fail to reject.
Right.
But then you could even work all the way through the problem, get to the end, and then say, okay, let's think about this problem. You know, what's happening here? You know, we're looking to see if the average is more, but the sample we collected has a mu that's actually less. So did we have to go through all of these steps, or could we really know the answer towards the beginning? But I think it's a great thought exercise.
I think we should put that in the next edition, girls.
There you go.
Absolutely.
Okay, great. Okay, another question from Shyla is, I didn't see an OGIVE presented, and I checked the index in the back. I didn't see it listed. Is that a concept that is not included in this edition?
You're correct. That is not included in this edition. Actually, frequency polygons are another one that are not included in this edition. Our second edition was actually a very large text. And so one of our goals in this book was to really see if there was any way that we could pare down some of the information and really focus on some critical concepts. And because in chapter 2, the availability of data analytics exploding just means there are so many different ways that you can display data that it would be impossible for us to show each and every different graph that's currently available. And there's new ones daily. And so we wanted to hit on some of the newer ones, such as heat maps. That's something that we had not talked about in chapter 2 in our second edition. And then we also, in our intro, pointed out to them that there are literally numerous ways that you can display data, and encourage them to even create their own unique ways of displaying data that are mathematically accurate. And so we didn't necessarily include every single way that we had in previous editions.
What a good project too, to say, go research some types of graphs that aren't listed in the text. And as an instructor, if you covered ogives and then some other ones that we took out, you could go back and mention those again and have your students say, well, what would it look like if you decided to display it in one of these ways? So.
Absolutely.
Great. I love how you're turning these questions into classroom exercises and group discussions. That's great to include the students as part of part of these issues that are coming up. So, okay, we've been getting some more Q&A, so let's keep going. Someone asked if you have lecture videos as well.
I don't believe that we currently do. Not that I'm opposed to that in any way, but I don't think that's something. Shirley, I don't believe we have those at this moment, at this time, correct?
No, we do have some videos that explain in the Hawk software. If there's an example, we have a video of someone working out the example. So we do have some videos, and there's also some introductions to the entire lesson that will go over what you can expect to learn in each lesson of the Hawk software. But there's not, they're maybe 10 minutes long versus a full lecture video. So, but we do have those video resources. Yeah. Okay, let's see. Another question from our Q&A is, what are your thoughts about having a course spanning group project where students have to collect, analyze, and interpret data? So I think this is focusing on doing those projects as a group work.
I was just looking at that question and thinking that's a great idea. We haven't done that. We have projects where within the project you do the whole thing where you collect, you analyze, you interpret your data, but they're confined to just, one project. But that's an excellent idea to have an ongoing project throughout the semester. Thank you for that idea.
Right.
Well, and I will actually, because I obviously had not shared this with those two, in my online class, I have a statistics survey that they take at the beginning that's anonymous and ask them all kind of bizarre things like their height and their weight and their, just any kind of weird variable. And I tried to make sure I had all different levels of variables so that we had nominal and ordinal and ratio and interval data in this survey. And they're told in the beginning that we're going to use this data completely anonymized throughout the course. And so then anytime I wanted to pull some data, then I wanted them to use a data set, I would pull in their height data from the class, or I would pull in their resting heart rate from the class. And we would do that. I also would even have them have their smartphone out and say, okay, if y'all are going to have it out on your desk anyway, text 5 people and find out how many times they were on Twitter today. And we would gather data like that in class and then use that set of data. And so it wouldn't build. I agree with Emily. I think that's a great concept for that to build, but it did allow me to continually tie back to this survey that we did at the very beginning of class.
And we actually have some large data sets online that I suppose if you wanted to take it from the beginning and every concept, go and have your students go look at the large data set, calculate different things as we go through them. They're not laid out as a specific, here's a project, but you could perhaps apply a lot of concepts to those data sets.
Great, thank you. Okay, we got a question here from Paul who says, I've used many textbooks for my elementary statistics course, and yours is by far the best value, so thanks.
Thank you.
At my college, there are 3 stats professors. I'm the only adjunct, and I face some pressure to use another textbook for consistency. Any advice on how I could push back on this and go with what I consider a superior textbook?
Well, have Shirley contact them. Show them this webinar, for one. I absolutely think that's the case. Lay out your case, in particular, the way we fit with the GAZE guidelines, all of the different methodology that we have in the book. That is what I would focus on.
And the software as well is just a huge tool.
Absolutely.
Superior to other softwares as well.
Okay, great. Yeah, go ahead and call Hawks. We'd be happy to help you make your case too. That's a great suggestion. So let's see. Okay, here's a question from Maury. It's great that you're emphasizing technology. You mentioned that you have explored various technologies, including R. Have you considered the statistical software RGuru, and are you aware that RGuru can be bundled with all Hawks products? I don't know if you authors know much about RGuru. Have you heard anything?
We didn't. I don't know. Now I'm curious, and we'll be researching this in detail.
Well, I guess I'll be taking this question then. Yes, Hawks has paired with Our Guru. Our Guru is an online, it's a website that uses the power of R. So in the background, it's using R code, but students don't have to know any coding. It's all point and click, and you can do hypothesis testing, and you can do all of your homework in Our Guru. So Hawks has paired with Our Guru, and yeah, if there's any more questions about that, please direct them to Hawks. We'd be happy to answer more about Our Guru. Okay, I wasn't sure whether the authors had heard of that one, so anyway. The next question is this text only suitable for service course like elementary stats, or is it appropriate for a business statistics course? Have you included business problems in each chapter?
I'll be happy to answer that one. Yes, we did try to include business examples throughout the entire textbook, as well as many others. So there's education examples. At my college, a lot of our nurses are taking statistics, so we included a lot of medical examples, and we tried to make sure we covered a wide variety. So it could be used for a psychology statistics class, it could be used for a business stats class. In fact, I've actually taught a business stats class with this text.
Great. Yeah, thank you. Okay, our next question is also about Our Guru, so I guess it's for me. It's what is the learning curve of getting data from Hawks into Our Guru? And Our Guru has, it's very easy to import data. It has, you can import it from Excel or a CSV file. There's just a pull-down menu that says import data, and you can import it in. It's pretty simple to import it from anywhere. Hawks has a copy data button on a lot of our data sets in the new questions for the BHE3 questions. If there's a table of data, instead of having to hand type that data into something else, if you wanted to work the problem in Excel or Our Guru, you can just copy it and then paste it into wherever you need to take it. Well, I've lost that question. I hope that answers. Oh, they also, Our Guru has a data repository of thousands of data sets that are just free open source data sets, just like R does. So they have access to all of those as well. Okay, let's see. I think I've gotten to the questions that we've had coming in. Let's see if I'm still getting them sorted. We've been getting so many, it's hard to keep track of which ones we've answered. So hopefully I think we've been able to answer all of the questions. So I guess we'll wrap things up. Thank you so much to our authors and to our audience for joining us today. We appreciate you all taking the time to talk about all of these interesting and exciting features and updates. If you have additional questions, please direct them to marketing@hawkslearning.com. Have a great day.
Yeah.
Thanks, everyone.
Bye. Thanks, guys.
Thank you so much.